Welcome friends to my channel. Today I am going to discuss gate of electronic and communication engineering EC, and subject is analog circuit. You can see the topic is Zener Diode switching circuit, and question is set by IIT Bombay, year 1993. The question is the wave shape of output voltage VO in the figure is. So here two diodes, Zener diodes, are connected back to back, and sinusoidal input voltage is applied, and the load resistance is here 10 kilo ohm, and what is the voltage will be here, it is being asked. Okay, so this is the Zener diode, this is another Zener diode. The input voltage all are connected in back to back. So before going to solution, here are the options, four options A, B, C, D. So before going to solution, let us understand some switching characteristic of Zener diode. So this is the Zener diode, and voltage V is connected. Let I is conducting in forward direction. Now this is the forward direction, and this is the reverse direction of applied voltage. So when Zener diode is forward biased, it behaves simply as a simple diode in forward bias. So it will be switched on, its resistance will be very small, so it will work just as a switch on as short circuit. But in reverse bias, the resistance will be very high, so it will be working as a open circuit, or Zener diode will be off. But once the reverse bias voltage crosses the Zener voltage Vz, a heavily current starts flowing, so Zener diode become on. So when Zener diode become on, it can be replaced by Zener voltage Vz, and here I have shown this. Okay, so Vz will be replaced by this. So you need to remember, where is its minus negative sign, there should be plus voltage, and where it is positive side, there will be minus voltage. Okay, now we can solve this question here. So this is the question. Now this is my input voltage. Okay, this is my what is this input voltage. Just a second. So input voltage is sinusoidally varying from plus 10 to minus 10, and these two value is also given, 4.1 and 4.1. So Zener voltages of both the diodes are 4.1 volts. This is given in the question. So here also 4.1 volt, here also 4.1 volt is the Zener voltage. So I have drawn this circuit, and 4.1 I have drawn one horizontal line, and minus 4.1 here also there is another horizontal line, and I have divided this whole input voltage as varying of time in 6 zones. So first zone, here I am writing regions, first region, second region, third, fourth, fifth, sixth region. First region, input voltage Vi is less than 4.1 volt and greater than 0 volt. So what will happen in this case? So in this case, you can see diode D will be on, because this is positive and this is negative. Vi is greater than 0, so D1 will be on, but D2 will be off because it is reverse bias. So I have written here D1 will be on, short circuited, because it is forward bias, and D2 will be off because it is reverse bias, and the voltage has not crossed the Zener voltage, so it is open circuit. So we can write this. This is short circuit, D2 is open circuit, and VO will be then 0 volt because no voltage is here. This is open. You can see here it is open circuit completely here. Here D1 is short circuit, D2 is open circuit. Okay. So now I can show this on this graph. Okay, I can show VO also in this graph. So VO will be just 0 up to this volt. Now in second region, VI is greater than 4.1 volt here. VI is greater than 4.1 volt. Now you can see when VI is greater than 4.1, this will be on, always on, D1 will be on, but D2 is now going into breakdown region. Okay, because it's crossing its breakdown voltage. So once it crosses the input is crossing the breakdown voltage, the diode D2 goes into breakdown region. So it must be replaced by VZ. Okay. However, D1 is on. Now this is the circuit I have drawn here. VI is there, D1 is on, but D2, diode D2 is replaced by Zener voltage VZ. So remember, this side will be plus and this side will be minus. Okay, because this Zener diode is like this. Here you can see. Okay. So what will be the output voltage? It is just VI minus VZ, because this polarity will be plus. I think this is minus. So VI minus VZ will be the output voltage. Now VZ is fixed 4.1, so you can subtract 5.1. It will be going to 5.9. So this point to this point, I am drawing VO. VO is going like something like this. Like this. So maximum point will be 10 minus 4.1 is equal to 5.9. Now what happens in third region? Third region is again VI is less than 4.1 and greater than 0. Okay, this is the third region. So it will be similar. Diode D1 will be on and diode D2 will be off. And what will be the circuit? Circuit will be same circuit here. So this circuit can be present. So VO will be 0. Again in fourth case, we can see VI now is less than 0 but greater than. So here I have written the VI value of VI is between 0 and minus 4.1. So what will happen? Diode D2 will be on now. Okay. So this terminal will become positive and this terminal will become negative. So this will become on, and at the same time D2 will be off because this will be driving into reverse bias. So D1 will be off due to reverse bias and this will be on due to forward bias. So this circuit, and in this case also, because this is open circuit, VO will be 0. But what happens when this fifth region, VI is less than minus 4.1 volt? When VI is less than 4.1 volt, diode D1 will be in the breakdown region, because now it is the direction of VI has been reversed and now it's going beyond the 4.1 volt. So diode D1 will go into breakdown region, and thus D1 must be replaced by VZ and D2 will be just on because it is forward bias, so it is short circuit. So D2 is short circuit and D1 is replaced by VZ. So here also you remember where will be the positive terminal, where is the negative terminal of Zener diode. So here we can write VO is nothing but VI minus VZ. This one. So we can draw here VO in red color. So this is 0. Here also VO is 0, but here it is just following the VI, but it is less than minus 4.1 volt. So its maximum value will go to minus 5.9 up to this. Again, the last region it will be 0 because again it comes to the same region. D1 will be on because voltage is between 0 to minus 4.1. So diode D2 will be on because it is forward bias, and D1 will be off because it is reverse bias and not conducting beyond the reverse bias, not conducting beyond the breakdown voltage. That's why it is just off. So we can replace this circuit here, and what will be the output voltage then? So output voltage will be just 0 volt. VO will be equal to 0 volt. So we can connect here. So this circuit, this output voltage waveform is only in the first option, option A. So answer is A. So thank you for watching this.